Hello! After the intro I will explain Ohm's law. Today we will talk about Ohm's law. It says electrical resistance is voltage divided by current. This means with a higher voltage at the same current the resistance is higher, or in the other way around, with the same voltage and a higher current the resistance is lower. To remember Ohm's law and its three formulas easier, you should think about the Uri triangle. In the Uri triangle, the voltage is in the top and the resistance and the current are in the bottom. In the base form, the Ohm's law is R is U divided by I, and you can see here you have R and U is in the top and I is in the bottom, U divided by I. In the next form we are looking for the current I is in the bottom, U is in the top and R is in the bottom, I is U divided by R. And finally we look for U is here and R and I are on the same level, so it's R multiplied by I. Now let's do some calculation to get more familiar with the Ohm's law. We have the voltage U which drives the current I, and the current I is limited by the resistance R. For exercise 1, the voltage is 12 volt, the current is 3 amp, how big is the resistance? Exercise 2, the voltage is 24 volt, the resistance is 2000 ohm, how big is the current? And for exercise 3, the resistance is 100 ohm, the current is 50 milliamp, how big is the voltage? Press the pause button and do the math for yourself. Here's the solution. U is in the top of Uri and I in the bottom, so R is U divided by I. With concrete numbers, R is 12 volt divided by 3 amp, R is 4 ohm. In the next example, U is in the top of the Uri triangle and R in the bottom, so I is U divided by R. With concrete numbers, I is 24 volt divided by 2000 ohm, I is 12 milliamp. And finally, in the last exercise, R and I on the same level in the Uri triangle, so U is I multiplied by R, U is 50 milliamp multiplied with 100 ohm, U is 5 volt. In our last example, we want to calculate the pre-resistance for an LED to drive the LED on a constant voltage source. The constant voltage source has 12 volt. From the data sheet of the LED, we know that it has 2 volt forward voltage at 10 milliamp. How big is the resistance? Press the pause button and do the math for yourself. Here's the solution. In the first step, we must calculate the voltage U1 at the resistor. We use Kirchhoff's loop law, where we know that the clockwise voltages are added, U1 plus U2, and equal to the counterclockwise voltages U. Now we bring U2 with minus on the other side, and U1 with concrete numbers is 12 volt minus 2 volt, U1 is 10 volt. Now we know U and I in the Uri triangle, U is in the top and I in the bottom, so R is U1 divided by I with concrete numbers, R is 10 volt divided by 10 milliamp, R is 1000 ohm. Finally, we want to do some measurements on a real setup. We have a constant voltage source U, we measure the current I, We have our 1 kilo ohm pre-resistance, we have the LED, and we measure the voltage U2 on the LED, the voltage U1 on the resistance, and the voltage on the complete chain U. Here our measurement setup. From the plus pole of the 12 volt supply we go through the amp meter, here's the display of the amp meter, and come with the red line to the 1K resistor, go via the 1K resistor to the LED, and from the LED via the black line back to the negative pole of the 12 volt supply. Now we will do our measurements. We see we have about 10.2 milliamp. At the LED we measure nearly 2 volt. At the resistor we measure a little bit above 10 volt, and over the complete circuit we measure 12 volt. So our measurements have shown the values what we have calculated, and everything works fine. That's all for today. If you like my video, give me a thumbs up and subscribe my channel. And to be informed about new videos, activate the bell. Bye bye.